Okay, so here are the notes for section 10.1, circles in circumference. Most of this is, most of this is definition work and some little bit of application, but mostly just kind of definitions and parts. So we've talked about parts of parallelograms. Now we're going to talk about parts of circles. Then do circumference. So other than probably some words and some specific ideas, really most of this should be review, but it's probably been a while. So first of all, definitions. The definition of a circle. Okay, a circle is the locus or set of all points, which locus is a fancy way of saying that, or location at least, in a plane equidistant from a given point called the center of the circle. Okay. So the way it works is you take a point in space and then make a bunch of points the same distance away from that, and when you do that, that creates a circle. Definitions as well. Radius is that distance from the center to the circle, but it's technically, if it's a segment, which is what they're talking about here, special segments, it's a segment with endpoints at the center of the circle and on the circle. Okay, so segment with the endpoints at the center of the circle and on the circle. So C to F, that is our radius. It's also called radii if it's plural, R-A-D-I-I. There are two other radii in there as well, CE and CD, but we're going to talk about those later. A chord, C-H-O-R-D, is a segment with endpoints on the circle. So AB right here has its segments on there, and so does DE. But DE is a specific type of chord called the diameter. So the diameter is a chord that passes through the center and is made up of collinear radii. It's a fancy way of saying it, but it's basically a chord that contains the center of the circle. That's like the easiest way to describe it. So a chord is, a diameter is a chord that contains the center. You don't really need this other part here, but it does make it nice and fancy. But it just really isn't that necessary. Okay, so the first example here real quick, I don't have it on your sheet because I didn't think I needed to, but real quick, which segment is not a chord? Okay, so yeah, I'll give you a second to figure that one out, and then we'll talk. Okay, so for this problem, if you look at AT is pretty obvious, it's a chord. Okay, it goes right from one part of the circle to the other part, so both endpoints are on the circle. CT, yep, both of its endpoints are on the circle. FN, there's our culprit. FN is not a chord, it's a radii. And then if you look at TN, TN also connects here. So the one that does not, the only one that doesn't, okay, only one that does not work that way is FN. Okay. All right, other relationships in a circle. If a circle has a radius in R and diameter D, the following is true. The radius is the diameter divided by 2, or it's half the diameter. And the diameter is double the radius. And I got a little drawing here to show you that. No matter what I do, let's change the font here. Font size, let's make it, I don't know, 18. That should be big enough for you to see. So A is the radius, D is the diameter. I probably just could have renamed this guy R, but you know, every time I work through this circle and change its size, this guy's always double this guy. So the radius is half of the diameter is double the radius. Okay. Circle pairs, other definitions here. Two circles are congruent if and only if they have congruent radii. That's important to understand. It's the radius that tells you if two guys are congruent or not. All circles are similar because they're all proportional. The proportion is their radius. And then the last probably definition here for this page here that you definitely should have heard of before is concentric circles. Concentric. If you go to Spanish, like con queso means with cheese, con, C-O-N, means with, and then centric means center. So concentric circles are just circles with the exact same center. Okay. They are again, coplanar circles that have the exact same center. Okay. Where you may have seen this before is with like Bohr's model of the atom. If you take physical science or do that in junior high, the concentric circle form of the atom. Bullseye is another place where you see concentric circles at. So there are a couple places you've probably kind of run into this before. You might not have called them by their formal name, but concentric means with the center. Okay. So here's a problem that involves finding the some measure in the drawing. So this one you do have in your notes. Okay. So the diameter of circle X is 22 units. The diameter of circle Y is 16 units. And WZ is 5 units. Find XY. So I'll have up here for a second for you to throw an answer in. If you get it right, let you jump to the next slide. Okay, so let's take a look at the drawing here. So the diameter is 22 units for circle X, and I don't think I've said this yet. This is my fault. You name a circle by its center. So circle X has center X. Okay. Circle Y has center Y. Okay. So here's the deal. We know that circle X has a diameter of 22. So if I went from here to here, this whole length is 22, which means really this radius is 11. So the radius for circle X is 11. WZ, okay, WZ is given to us. It is 5 units. Okay. The question is, what is XY? Okay. Oh, we left out one more part too. The diameter of circle Y is 16 units. So, whoops. Got a lot of drawing here. Well, the diameter of circle Y is 16. The radius, which is what YW is, has to be then 8. Okay. So the question is, what is the length of XY? So let me just draw the segments out, because I think it'd be easier if I look at it that way. All this circle stuff is just kind of gotten a little bit confusing. So here's X, W, Z, Y. Okay. So we know that XZ is 11. We know that WZ is specifically 5. And we know that WY is 8. Okay. So we need to figure out is what are XW and what are ZY, and then we can just add those 3 parts together. Okay. Well, if this guy's 11 and this guy's only 5, that means XW has to be 6, because 6 plus 5 has to add to 11. And if WZ is 5 and WY is 8, that means that ZY has to be 3. Now I know this isn't to scale, but who cares? So now I would add all up the 6 plus 5 plus 3, which gives me 14. Not the last question, but kind of the last idea for this section is circumference. And the thing about circumference is you have to kind of piece together a special formula first. And that is how we get circumference. Well, I've got it up here on the drawing. Circumference, actually we don't find the formula directly, we actually find it indirectly. Someone realized a long time ago, and hopefully this is legible on your screen, that if you take any circle, no matter how big or how small it is, and you divide the circumference by the diameter. So my circumference is 14.23, my diameter is 4.53. If you take circumference divided by diameter and divide those every single time, as long as it's a perfect circle, you get 3.14. Now this stuff about arc length and stuff, don't worry about that. That's for another lesson. I just have it all in the same drawing. And this angle here as well, ignore the angle. So every time the circumference divided by diameter is 3.14. Well, what somebody decided to do is they said, hey, let's just define that as pi. So I said, okay, circumference divided by diameter equals pi. And then they said, well, I can solve for the circumference by multiplying both sides by the diameter, canceling off the diameter. So circumference is pi times diameter. And then earlier on we said, oh yeah, don't forget diameter is 2 times the radius. So circumference is pi times 2r. And then what happens is it just gets rewritten as 2 pi r. So those are our 2 formulas for circumference. Okay. So yeah, sorry, here they are. Scroll back here. So circumference equals pi d or 2 pi r. So here we go. First problem, crop circles. A series of crop circles was discovered in Alberta, Canada on September 4th, 1999. The largest of the three circles has a radius of 30 feet. Find its circumference. Okay, so let's take a look at this problem. So we have to figure out, what do we have? I have a circle, looking for circumference, and they gave me the radius of 30 feet. Okay, so if I know r is 30, I could do one of two things. I could find the diameter, which is 2 times 30, which is 60 feet then. Or I could just use circumference and then do circumference equals pi d. Or I could just do 2 pi r and plug 30 in for that. Either way, I'm going to get (60 pi feet), or pi times 60, which is still 60 pi feet. Now, one of the things we get to do in geometry that you might not have done before is we'll do what we call leaving it in terms of pi, which means we just leave the pi there. We don't mess with doing any of the work of multiplying it out. If that bugs you, you can always grab your calculator and just simply do 60 times pi. And you get 188.4955 and some change. So if that really bugs you, you can do that. But I'm kind of lazy. I like to leave it in terms of pi if I can. Okay, next problem then. Again, still working with circumference. This time we want to find the diameter and the radius of a circle to the nearest hundredth if the circumference of the circle is 65.4. Okay, so in this case, they've given it to us in terms of 65.4 feet. That means they've used the pi button on the calculator, or if you don't have a calculator with pi, 3.14. Okay. But either way, we got to find the diameter and the radius. So what I'm going to do is I'm going to find the diameter first, because it's just simply pi times diameter. So 65.4 equals pi times d divided by pi. And now I can just throw that into my calculator, 65.4 divided by pi. Let's say go to the nearest hundredth. Well, that gives me then that it is 20.82. And what is this? Feet is the units. Okay. And then if I want the radius, just divide that by 2, which is 10.41 feet. There we go. Okay. So a couple more definitions inscribed and circumscribed. Okay. Scribe means to write. That's all scribe means. So a little word for you today. Scribe equals to write. Okay. So in that case, I'm saying inscribed. That means write inside. It means to put it inside, written inside, however you want to think of it. So a polygon is inscribed if when you draw it like this guy here, L, M, N, P, all the vertices are inside the circle. Or on it, should say. Technically it's on it. Inside it would mean it doesn't even fit in it. If a circle is drawn around a figure and it hits all their vertices, we call that circumscribed, because circa means circle. So circumscribed. So quadrilateral LMNP is inscribed inside the circle, and circle K is circumscribed about the quadrilateral. So our next example then is kind of using that, using the fact that I've got a circumscribed triangle to find the circumference of circle K. So take a second, try it on your own. This was probably kind of tricky though. Alright, so for this problem, you have to make one realization. Otherwise, it's not impossible, but it's very, very difficult. And that is the fact that this is a little right triangle here. And not only that, since this to this and this to this are radii, because K is the center, they're congruent, making this guy a 45, 90. Which means if the hypotenuse is 3 root 2 of that 45, 90, the leg, or the radius in this case, is 3. So circumference is 2 pi r. So circumference is 2 pi times 3, 6 pi. Which if you don't like having it as 6 pi, again, just go grab your calculator. 6 times pi. And that is 18.84 or 85. Yeah. Okay. Yeah.